Hello and welcome students. As you all know, in the last video lecture, I had explained to you question number 7, 9 and 10 of exercise 2.2 of your textbook. Now, I will continue with the same exercise, question number 12. First of all, let me read the question. Find the correlation coefficient from the following information of rainfall, that is x in centimeter, and yield, that is y in tons per hectare, for the last 10 years of a district. Here you can see in the question that all the data are ready-made given to you. You don't have to calculate the value of sigma x, you don't have to calculate the value of y and so on. So here, according to the data given to you, you have to apply the formula. In the previous video lecture, I had already explained to you the various formulas that can be utilized for finding the value of r. If required, do revise that video lecture again so that you will get the clear idea of all the formulas that can be applied depending upon the data that has been given to you in the question. Over here you can see that is the value of n that is given to you 10. Covariance of xy that is given to you 30, and Sx means standard deviation of x that is given to you y, and standard deviation of y square means it is given to you variance. See, in the question you can see that is variance of y that is given to you 144. If from variance to find the standard deviation of y, you have to find the root of the variance. By finding the root of variance, you will get the value of standard deviation. So 144, root of 144, it will come to 12. So the value of standard deviation of y, that will come to 12. Because according to our formula of r, we have to apply over here, that is covariance of xy upon standard deviation of x into standard deviation of y. We cannot write here standard deviation of y square. So from standard deviation of y square, that is covariance, we have variance of y, we have found out the value of standard deviation of y, that is root of 144, that is 12. Okay, so first of all, applying in the formula, this formula was the first one, that video lecture that I had explained, that is r is equal to covariance of xy upon standard deviation of x into standard deviation of y. Students, in exam, you have to spontaneously realize that in this sum, this formula has to be utilized depending upon the question, the data that has been given in the question. So over here, covariance of xy, what is the value of covariance of xy? That is 30. If you are knowing immediately which formula will be applied, the calculation would be quite easy for you. So 30 over here, the covariance of xy upon standard deviation of x, that is given to you 5, and standard deviation of y that we have found out, that is 12. So 30 upon 12 into 5 will come to 60. So 30 divided by 60, orally also you can do, that is 0.5. So the value of r that will come over here, that is 0.5. Now the next sum, that is 13th sum. First of all, I am reading the question number 13. From the following information is obtained regarding the height, that is x, and weight, that is y. Here also the data has been given ready-made to you. You don't have to calculate the value of x bar, y bar, sigma xy. It has already been given in the question. So the following information of height x and y from a sample of 10 students of a school. Here the values are given to you, 10 students of a school. So value of n, it would come to 10. Number of observations, that is of 10 students. So value of n, that would come to 10. X bar value that has been given to you, that is 160. Y bar that has been given to you, 55. Sigma xy that is given to you, 90,000. And Sx is given to you 25, and Sy, that means standard deviation of x and standard deviation of y. These many values are given to you. Now you cannot apply the formula over here, that is sigma x minus x bar, y minus y bar, or n sigma x y minus sigma x into sigma y. You have to depend upon the data that has been given to you. Over here, according to the given data, you have to apply the formula of r, that is sigma xy minus n x bar y bar upon n into Sx into Sy. So sigma xy, just placing all the data that has been given in the formula. So sigma xy, that is 90,000 minus n value, that is number of observations, 10 students, so 10, into x bar that is given to you 160, and y bar that is given to you 55, upon n that is 10, Sx that is standard deviation of x that is given to you 25, into standard deviation of y that is 10. So 25 into 10 into 10, that will come to 2,500 in denominator. In numerator, that is 90,000 minus 160 into 10, it will come 1600. 1600 into 55, it would come to 88,000. So 90,000 minus 88,000, it would come to 2,000. 2,000 divided by 2,500, the value of correlation coefficient, that would come to 0.8. So this way it depends which formula has to be utilized in which sum according to the values that has been given to you in the question. Now moving on to question number 14 of your textbook. In that there are two sums, so I have written over here 14.1 and 14.2. First of all, 14.1, determine the value of correlation coefficient from the following data. The first question 14.1, the data already I have written in the board on the board, that is sigma x minus x bar whole square is given to you 72, sigma y minus y bar whole square that is given to you 32, sigma x minus x bar y minus y bar is given to you 45. So here you can easily remember the formula that was utilized, that we were utilizing when the value of x bar and y bar were integers. We are utilizing this formula. If you remember, that is sigma x minus x bar y minus y bar upon under root of sigma x minus x bar whole square into under root of sigma y minus y bar whole square. Simply you have to place all the data in the formula. So first of all, sigma x minus x bar y minus y bar whole is given to you, that is 45. So 45 upon sigma x minus x bar whole square that is given to you 72. So 72 into under root of 32, that is sigma y minus y bar whole square. Now is equal to 45 upon, by multiplying 72 into 32 it would come to 2304. That will be again in root, because 2304 we have to find the root of it. After finding the root it would come to 48. So 45 divided by 48 it would come to 0.94. Now 14.2, in which also the data has been given to you, that is n is equal to 6. Sigma x is equal to 16, sigma y 51, sigma xy that is 154, sigma x squared that is 52, sigma y squared that is 471. Easily you can make out from the data which formula you have to utilize. That is the main basic formula we are utilizing. That is when the value of x or bar, x bar or y bar, any of it or both of them are in fractions, then we are generally utilizing this basic formula, that is n sigma xy minus sigma x into sigma y upon under root of n sigma x square minus sigma x whole square into under root of n sigma y square minus sigma y whole square. So first of all, n value, that is 6 over here, sigma xy value that has been given to you, that is 154 minus 16 into 51 upon under root of n, that is 6. Sigma x square value that is given in question 52 into sigma x, that is 16 whole square into under root of n, that is 6. Sigma y square that is given to in question, that is 471 into under root of into sigma y whole square. Sigma y value that has been given to you 51, so 51 whole square. Now just doing the multiplication, division and subtraction of all the values. So first of all, multiplication of 154 into 6, it would come to 924. 924 minus 16 into 51, it would come to 816. Subtracting both the values, it would come to 108 in numerator. Now in denominator, first of all 52 into 6, it would come to 312. 312 minus 16 square, 16 into 16, it would come to 256. So 312 minus 256 into 6 into 471, that would come to 2826 minus 51 square, it would come to 2601. By doing the subtraction of these two values and doing the subtraction of these two values, 312 minus 256, it would come to 56. It will be still in under root, because we have to find the root of these two values, into under root of 2826 minus 2601, it would come to 225 under root. Now first of all, do the multiplication of these two values, that is 225 into 56, and then find the root of the answer. You will get 112.25. So by dividing the numerator with the denominator, 108 upon 112.25, the value of correlation coefficient, that will be 0.96. Now moving on to last question of exercise 2.2, that is question number 15. The question is, find the value of r from the following data. Here it is given particulars x and y, in which first of all it is given average, that is 60 and 95, average of x and average of y. Average means x bar and y bar, you are knowing very well. So value of x bar that is given to you 60 and y bar that is given to you 95. Here directly it is not given x bar and y bar, but it is written average. So it is understood that x bar and y bar, that is 60 and 95. Next column, it is given the sum of squares of deviations taken from their mean. Deviations taken from their mean. Square means, over here you can see square. Deviations taken from their mean. So x minus x bar. Mean means x bar. Sum means sigma. So sigma x minus x bar whole square, that is given to you 920. In the similar way, it is given for y. Sum of squares of deviations taken from their mean. So in case of y, here from their mean, that means y bar. Sum of square, sum means sigma, and square means over here you can see raised to 2 is given to you. So sigma y minus y bar whole square is equal to 1050. Directly the value, that is sigma x minus x bar whole square or y minus y bar whole square, is not given to you, but it is written that is sum of squares of deviations taken from their mean. So you have to understand this is the value of sigma x minus x bar whole square, and 1050 is the value of sigma y minus y bar whole square. Now the last value, that is given sum of product of their. Product means multiplication. So multiplication of these two values has been given to you. See, the sum of product of deviations taken from their mean. Deviations taken from their mean. Sum of product. This is the sum. Sigma means sum. Sum of the product of deviations taken from their mean. So sigma x minus x bar whole square into sigma y minus y bar whole square. So it would come to you minus 545, that is given. So these are the values that has been given in the question. So first of all, you have to identify it. Now seeing the data, you can easily identify which formula we have to utilize over here. That is sigma x minus x bar y minus y bar upon sigma x minus x bar whole square into under root of sigma y minus y bar whole square. Now one question should be arised in your mind, that if these three values are only required in the question to find the value of r, then why the value of x bar and y bar is given in the question? Now students, the value of x bar and y bar is just to misguide you. Only the basic three values that are required in the sum, that is of x bar, x minus x bar, y minus y bar upon sigma x minus x bar whole square and sigma y minus y bar whole square. Only these three values are important to find the value of r. This is just to misguide you. So no need to take stress for it. Now moving on to the calculation of it, directly just placing, after deciding the formula, we will just place the values in the given formula. That is sigma x minus x bar y minus y bar is already given to you, that is negative 545 upon under root of x minus x bar whole square, that is given to you, that is 920 into under root of sigma y minus y bar whole square, that is given to you, that is 1050. So minus 545 upon multiplication of this two, that is 920 into 1050, it would come to 966,000. It means 9,66,000. And that will be the multiplication of these two values. It will again be under root. Now minus 545 upon, we have found the root of 9,66,000. By finding the root, it would come 982.85. By subtracting the numerator from the denominator, you will get the value, that is negative 0.55. So the value of correlation coefficient, that is r, is coming over here, that is minus 0.55. So students, that's the end for today. Till now we have understood the question number 11, 12, 13, 14 and 15. In the next video lecture, I'll be starting with the next method, that is Spearman's rank correlation method. Till then, revise the sums related to Karl Pearson's method by practicing from the previous video lectures. Till then, goodbye, stay blessed.